Hello once again and welcome to mathematics class. Of course, in this class we are going to be looking at logarithms, mathematics, and in this class we are going to be looking at logarithms. All right, so for the purpose of this class, it's a JAMB class, of course, so we have to just leave some nitty-gritties and jump straight to why we are here. Right, so we're going to be solving a lot of questions in this topic. We're going to see the laws guiding logarithm. In essence, we see the laws guiding logarithm, and then we will solve questions on logarithm. We take assignment to test ourselves, and of course, you yourself, you have to do your part. Do not forget that this video is proudly sponsored by O3 Schools, O3 Schools JAMB app. O3 Schools JAMB app is the best CBT practice app available. It's available for both Android and for your laptops. It's not yet available for iPhone as at the time of shooting this video, but of course, it will soon be available. We are very, very well underway with the development of the iPhone version or the iOS version. All right, this JAMB CBT app has all the past questions you will need to prepare for your exam. Then, of course, there are mock exams that you can set for yourself. There's also a UTME challenge where all JAMBites compete to see how prepared they are for the examination. So it is designed, the app is designed just like the way you see on your exam day. So you have to practice with it very well, practice all the questions on the app, and then follow our tutorials. You see that you'll come out with flying colors. So the activation of the app is not free anyway. The free version allows you to answer just 5 questions. After you have answered 5 questions, you need to activate the app. So that is how the app works. The activation is just 2,500 naira. This is a small infinitesimal token that what you are giving to us. You are paying for to say thank you for such wonderful app that has been created to aid your success. There are a lot of testimonies from people who used it last year, and your case will not be different. So without further ado, let's hit the road on logarithm. So let's quickly look at the laws of what? Of logarithm. Laws of logarithm. We have seen laws of indices in the previous class. We're going to see laws of logarithm. If you have not watched indices class, please pause this video now and go to the previous video, watch indices, understand it very well before you jump into logarithm. So number 1 law. So if you have log mn base b, for example, if you have log of what? M times n base b, it means it's equal, this is same thing as equals to log what? M base what? B, then plus log n base b. It's as simple as A, B, C. So that, for example, e.g., if you have log 30 base 6, the same thing as what? Log what? What is 30? 6 times 5 base what? Base 6. So equals to log 6 base 6. Then plus what? Log 5 base 6. So if you have something like that, that's how you simply simplify it. There's nothing more, nothing less. So let's look at another law. Have log. This was multiplication. If you have division, log m over n base b, the same thing as log now. You know, here we add addition, so here we're going to have what? Subtraction. Simple as ABC. Log m base b minus log n base b. It's as simple as ABC. So that you have something like log 81 over 3 base 3. The same thing as what? Log of what? 81 base 3 minus log of what? 3 base 3. Of course, you can continue from there. Now, another law of logarithm is if you have log of m raised to power n base x, for example, or let me use base b again, as I'll be using m raised to the power of n base b. So what you now have, this n comes to this back of this log. So I'm going to have n log m base b. Base b. Very, very, very what? Simple. So for example, if you have something like log of 2 raised to power 3 base 2. So the same thing as what now? Saying 3 log. So 3 comes to the back of the log 2 base 2. So these are the fundamental ones. The fundamental laws of logarithm we have. But we have some other wonderful laws. Some other wonderful laws of logarithm. The board will not be sufficient enough for me to put everything. But let me see how I can merge them together. There's another law that says log of, let's say log of what? B to base B. Logarithm of is B to base B. Logarithm of a number to the same base. Logarithm of the same number to the same base is what? It gives us what? 1 in this condition. So if you have logarithm of a number to the same base, it is 1. For example, here now we have logarithm 3 log 2 base 2. Log 2 base 2 is what? Is 1. So this solution will be equal to what? 3 times 1, which is what? 3. As simple as ABC. So logarithm of a number to the same base is what? Is 1. Then we also have this number 4, then number 5. We also have the last one, logarithm of 1 to a base. Logarithm of 1 to a base is 0. So if you have, for example, log 1 base 3 is equal to what? Now 0. Log 1 base 10 is equal to what? 0. Logarithm of 1 to any base will give you what? 0. So these are the fundamental laws of logarithm. Let's go over them again so that we understand before we start answering questions. All right. So we said what? Logarithm of m multiplied by n. So the multiplication, if you're having multiplication, what you simply do, you add, you separate and add. So you have logarithm of n base b plus logarithm of n base b. Now, give an example here, you should follow through to see. Now we have a logarithm of m over n. If there's a division, what you do, the division sign turn to what? Subtraction here. So you separate and subtract. So if you're having a power on top of the number, so it simply is what? N, you bring the number to the back of the logarithm and then m base b, which is here. The logarithm of a base of a number to the same base will give you 1, while logarithm of 1 to the base is what? 0. So having seen this now, we're going to see how to simplify logarithms. Let's take some questions from, of course, any question we take here is a JAMB question. We do not treat kindergarten questions here. It has to be a JAMB question. JAMB question, correct JAMB question. Question that will shock you, that will move you. All right, let's go. So how about 1979? I'm joking when I say to move you. Well, the purpose of us solving past questions from JAMB is so that I want you to know that JAMB is very easy. JAMB is very, very easy. If you can answer this question, then there's no way they will tweak the question. There's no way, there's no angle they will tweak the question that you will not understand. I will not know, I will not be able to know how to solve it. So it's that easy. So let's go using 1979 question number 2. So they said, number 42, they said, what is logarithm of 49 raised to power a base 7 minus log 0.01 base 10. All right, so solution, we're given 49a over 100. 49 raised to power a over 100. B is a over 2 plus 2. C is 7 raised to power 2a plus 2. And D is 2a plus 2, while E is 2a over 2. So let's see how we can apply the laws we have learned from logarithm to solve this question. So now let's go. So we already know that what? 49 is what? 7 times 7, Abi? Right. And then here, also you know that here 0.01 is written as what? 10 to the power what? Minus 2. So those are the only two things, the only key points you need to know here. So look at it, 0.01 is something as well 1 over 100, which is equal to what? 10 to the power minus 2. So we can use it to solve this question conveniently. Now, having known those two things, let's begin. So I'm going to have logarithm of what? 7 raised to the power 2 times what? A over 7 minus logarithm of what? 10 to the power minus 2 base 10. Are we together? Yeah. So of course, there's a minus here, there's a minus here. If this has to come down from that logarithm law, because there's raised to power minus 2, if it's coming down, that means you have to take note of your sign. In fact, I will not be surprised if the examiner who said this question purposely want to make you fail it. So minus times minus will be plus. So be very careful. Now we're having what? 2 times a is what? So I'm going to have logarithm of what? 7 raised by 2a base 7 minus logarithm of what? 10 raised by minus 2 base 10. So 2a will come to the back of this log. I'm going to have 2a. Logarithm of a number to the same base is what? Is 1. So 2a times 1 minus what? So minus into bracket minus 2 will come to the back of this logarithm into bracket minus 2. The logarithm of what? 10 to base 10 is what? Is 1 times 1. So I'm going to have 2a minus times minus is what? Is plus. Plus 2. 2 times 1 is what? Is 2. So our answer is what? 2a plus 2, which is what? Option D. You see how easy it is. So we follow the rules. We follow the rules of logarithm to what? To solve the question. So let's quickly go to another question. We have lots of questions to attempt, so we have to be very fast and not sleep on anyone. So we have 1982 basics. Right? So we are told what? To simplify logarithm of 8 to base 10 minus logarithm of what? 4 to base 10 all over logarithm of 4 to base 10 minus logarithm of 2 to base 10. So A is given logarithm of 2 to base 10, B is logarithm of 8 to base 10, C is 0, D is logarithm of 4 to base 10, E is 1. So let's solve. It's very easy. So we already know the rules of logarithm, so let's convert it to 8 is what? 2 raised by what? 3. So I'm going to have let's convert this to what? To index form. The index form what? 2 raised by 3. So I have logarithm of what? 2 raised by 3 base 10 minus logarithm of 4 is what? 2 raised by 2 base 10 all over logarithm of what? 2 raised by 2 base 10 again, right? Then minus logarithm of 2 raised by logarithm of 2 to base 10. So we have simplified this to this. Now we know what the rule says. So 3 comes here. So this is equal to 3 log 2 base 10 minus 2 log 2 base 10 all over 2 log 2 base 10 minus what? Log 2 base 10. Right? So we can subtract now. 3 log 2 base 10 minus 2 log 2 base 10 will be what? Log what? 2 base 10 or 1 log 2 base 10. And because there's no need for us to put the 1 there, so we can just let 1 go. So log 2 base 10 all over what is 2 log 2 base 10 minus log 2 base 10? 2 minus 1 is what? Is 1. So I'm going to have again log 2 base 10 here. Right? So log 2 base 10 will cancel log 2 base 10. Our answer is 1. So you see how very easy it is. Just in 2 steps, we have answered our question. So that's how logarithm is. It's that easy. So it's that easy. Know it, know the laws in your head, and know peace. And you see that everything will become very easy for you when solving. All right, let's go to another question. Another question here is 1980 number 18. 1980 number 18. So they say simplify log 8 base 10 over log 4 base 10. So they said A answer is log 2 base 10, B log 4 base 10, C 3 over 2, D 2, E none. So let's solve. So this simple. So what do? The same thing. 8 is 2 raised to the power 3. So I'm going to have logarithm of what? 2 raised to the power 3 base 10 all over logarithm of 4 is what? 2 raised to the power 2, right? 2 raised to the power 2 base 10. Am I too fast? I guess I'm not. I've understood the laws. If you understand the laws, this will be easy to follow. But if you don't, I beg you, I'm sorry. So I'm going to have now 3 will come to the back of log 2 base 10. So I'm going to have 3 log 2 base 10 all over what? 2 log what? 2 base 10, right? So log 2 base 10 will cancel log 2 base 10. What is left is what? Is 3 over 2. Option C. You can see how very easy it is. It's very easy to solve. So let's go to another question. So another question here is a 1990 question. 1990 question number 10. It says simplify 3 log 9 basis plus log 12 basis plus log 64 basics minus log 72 basics. All right, so what do we do here? Now, from the law of logarithm, we know that whenever we're having addition, we are multiplying. If you're having subtraction, we are dividing. So that has already given us what? A foothold on what to do. So now the only thing that is left here is this. So let's take it back to the index form. So I'm going to have logarithm of what? Of 9 raised to the power what? 3 base 6 bar, then plus log 12 base 6, then plus log 64 base 6 minus log 72 basis. If you're in the exam hall, this is not what. See, if you're in the exam hall, the first thing you should just do after seeing this is to just say, next part 3 times 12 times 64 divided by 72. That is the next thing you should be doing. So you bring out what your log says here. You get? So you can now start simplifying to get to start working towards your answer. Right? But let us do it clearly so that everybody sees it now. Because your exam hall is not, you have to be fast, you have to be accurate also. So, right, JAMB want to test your speed, they want to test your accuracy. There will be no need for speed if you are failing all the question. You have speed and you are failing, you are making mistakes up and down. So you have to be very accurate even while trying to be very fast. So now let's do that. So I'm going to have logarithm of what? 6 into bracket 9 raised to the power 3 times, this is plus, that is times 12. This is plus again times what? Times 64. Then divided by what? 72. Alright, so what do we have? Let's try to simplify. Alright, so 8 times 9 is 72 bar. Right, so this is what? 8 can go into 72 9 times. So what can go here? 8 times 8 is 64. So 8 will go here 8 times, 8 will go here 9 times. Alright, so what else? 3 here, 3, or instead of saying 3 here, 3, this is 9, right? Let us say 9 into 3 is what? 9 here 1, 9 here, 9 raised to the power 2, isn't it? Hope we are following clearly. Alright, so we are done with this down part. So we're going to have logarithm of what? Base 6 into base 6 into brackets 9 raised to the power 2 times 12 times 8 bracket back. Alright, so let us minimize space. Let's minimize space rather. So this is what we have left. Then 9 raised to the power 2 times 12 times 8. So we're still simplifying. We can simplify further. 9 raised to the power 2 is something like what? 3 raised to the power 4. You get 9 times 9 is equal to 3 times 3 times 3 times 3. You get? So that's why I'm saying 9 raised to the power 2 is something as what? 3 raised to the power 4. So logarithm of base 6 is equal to what? 3 raised to the power 4. Then times 12 is something like what? 3 times 4. Then times what? 8. All together. So 3 times 4 is 12, then times 8. We are simplifying, right? So we're going to have logarithm of 6 into bracket 3 raised to the power what now? 3 times what? 3 raised to the power 1 times 3 raised to the power 4. Same thing as what? 3 raised to the power 4 plus 1, which is what? 3 raised to the power what? 5. Then times what? 32. What is 32? 32 is same thing as what? 32 is same thing as what? 2 raised to the power 5, isn't it? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So that's the same thing as what? 2 raised to the power 5. That means, of course, we can continue here and say logarithm of 6 into bracket 3 raised to the power 5 times what? 2 raised to the power what? 5. Now, what do we do? What do we need to do again? Now, to make this, because we are trying to simplify, that's why we are doing all this. So if I gotten here, what can we do again to make, can we further simplify? Yes, we can. Now, this same thing means what? Logarithm of 6 into bracket what? 3 times 2 all raised to power 5. Abi, it's the same thing. Because this is 3 raised to power 5 times 2 raised to power 5. That means 3 times 2 raised to power 5 is the same thing as what? This. So then what can we do? 5 can come to the back of log 6. We're going to have 5 log what? 6, right? 5 log 6, then 3 times 2 is 6 log 6. So, but we now have what? 5 log 6 base 6. The logarithm of a number to the same base is 1. So I'm going to have 5 times 1, which is equal to what? 5. So I'll be able to simplify this to 5. Let's go back again. Understood from here, logarithm of understood how this became now 9 raised to the power 3, because this is 3 log 9 base 6. If here was raised to the power 3 before, the law say we should bring it behind the logarithm, right? So since it is behind the logarithm, we can take it back up to where its original position was supposed to be. So we now, whenever we're having addition, we multiply, we divide, because we're having subtraction here. So we did this, and then we did little reduction. We reduced the figure, and then we got this. Then this 12 is stated at 3 times 4. So that we added it to that 3 raised to power 1 to that 4 to give us 3 raised to power 5. 32 is same thing as what? 2 raised to power 5. Then at this point, we now have 3 raised to power 5 times 2 raised to power 5. But of course, since they are all raised to power 5, the 5 is affecting both 3 and 2. We can bring out the 5 out. So that 5 came back to back of 5 log 6. Back of log 6 rather, right? Then we have 5 log 6 base 6. And the logarithm of a number to the same base is 1. That's why we arrived at 5. So do the question by yourself again in case you are confused. I know some of you may be confused too, but there's no need to be confused. Just look at the question again and solve it yourself. All right, so let's go to the next one. So this is a 1991 question. 1991 question 9. They say simplify 2 log 2 over 5 minus log 72 over 125 plus log 9. Is that 9? Yes, it's 9. So we have so many options, but of course we don't want to spend time writing out all those options. So now let's go. This is the same approach, right? So here we're having 2 log 2 over 5. So what are we supposed to do here? These 2 can come to the power of 2 over 5. That is the natural position. So I'm going to have logarithm of 2 over 5 all raised to power 2 minus logarithm of 72 over 125, then plus logarithm of 9. I have to be very careful so that I do not miss any step. Let me rule so that I'll have space to solve it in one without cleaning. All right, so now let's go there. So I'm going to have logarithm of 2 raised to power 2 is what? Is 4. 5 raised to power 2 is what? Is 25. Then minus logarithm of what? 72 over 125. Then plus logarithm of 9. Right? So you remember that whenever we're having division, we what? Subtraction, we divide. Having addition, we multiply. So there's a plus here. So this one is positive, this one is positive. So I can say logarithm into bracket 4 over 25 times what? 9 over 1, then times, we divide, because having what? Minus logarithm of 72 over what? 125. So I'm supposed to divide by what? Divide this by this. So we're going to have divided by what? 72 over what? 125, right? So, but of course, we need to what? Solve. So we cannot solve with division. We have to change it to multiplication. So I'm going to have logarithm of what? 4 over 25 times 9 over 1, then times what? 125 over 72. Understood why it came up, right? Because if I'm changing this division sign to multiplication sign, we have to invert what? The fraction. So now we can now decide to what? To reduce this fraction to the barest minimum. 25 here 1, 25 here 5. 25 times 5 is what? Is 125. All right, so what else can divide, right? So 9 year 1, 9 year can go 8 times, right? And of course, 4 year 1, 4 year 2, right? So what is left? Is anything still left? So we're having what? Log what? Log, log 1, log 1 over 2. Because 1 times 1. Okay, sorry, this is not log 1 over 2. This is 1 times 1. You have to be very careful. You see, I already started throwing away the 5 here. So I'm going to have logarithm of 1 times 1 is 1. 1 times 5 is 5. Over 1 times 1, 1. 1 times 2 is 2. So I have a logarithm of 5 to what? The logarithm of 5 over 2. So of course, this one can also be simplified to what? Logarithm of 5 minus what? Logarithm of what? Of 2. So, but looking into my questions, because I went to relax just now to see, it's not in the question. So it's not in the options rather. So A, we're given 1 minus 4 log 3. B, we're given minus 1 plus 2 log 3. Then C, we're given minus 1 plus 5 log 2. Then D, we're given 1 minus 2 log 2, right? Those are our options. Those are our options. So we're not giving what this answer in our option. It's not there. This means that we can further simplify this. Or to further simplify this, we will get an answer. So now what can we do? Right? We know that what 5 is something about 10 over 2. 10 over 2 is what is 5. So now let's impute 10 over 2 in place of 5. So I have logarithm of 10 over 2, then minus what? Logarithm of what? Of 2. So I'm going to have logarithm of what? Of 10. Because from our rule, we say if there's division, we have to subtract and separate what the logarithm. So I'm going to have logarithm of 10 base 10. This is base 10, right? Really, minus what? Logarithm of what? 2 base 10 minus what? Logarithm of what? 2 base 10. Logarithm of 10 to base 10 is what? Is 1 minus what? Minus 2 log 2 minus 2 log 2 is equal to what? Minus what? 2 log 2 base 10, right? So this will be our final answer. And of course, the answer is in the option. Are we together? So, all right, now after seeing this, we are going to another aspect of logarithm that has to do with us substituting values into what our given question to get the final result. So we're going to substitution in logarithms. Substitution in logarithms. I'm going to take examples under substitution in logarithms. So now, an example here is 1988, question 9. So they said, if log 2 is 0.3010 and log 3 is 0.4771, they said find log 45 base 10. So we're given what? The value of log 2 and value of log 3. And we're told to find what? Log 45 base 10. Is it 4.5 or log 45? What we're told to find out log 4.5 base 10, rather. Log 4.5 base 10. So our options: A 0.301, 0B 0.4771, C 0.6532, and D 0.9542. All right, so solution is very easy. So bring out your log. I'm going to have log 4.5 base 10. This 4.5 can be expressed to what? To fraction. So you move once, so it will be over 10, isn't it? So I'm going to have logarithm of 45 over 10 base 10. Are we together? So we have logarithm of 45 base 10. Logarithm of 45 over 10 base 10. So now can we reduce this? 5 here can go here 9, 5 here can go here 2 times. So I'm going to have logarithm of what? 9 over 2 base 10. Can we simplify this? Yes, we can. So I'm going to have logarithm of 9 base 10 minus what? Logarithm of 2 base 10. Of course, this is the same thing as what? Logarithm of what? 3 raised by 2 base 10 minus what? Logarithm of 2 base 10. And bring 2 to back of this log. Now 2 log 3 base 10 minus what? Log 2 base 10. So if I've gotten to this point, all you need to do is to bring in the values. So I have 2 into what is log 3 base 10? 0.4771 minus what is okay, bring, you have to close this because you are multiplying this by 2, then minus 0.3010. So if you multiply this and subtract this, your answer should be C 0.6532. All right, so that's the question and very, very easy to solve. All right, so we're seeing substitution. Let's take one more example under substitution of logarithm. This is a 1997 question. 1997 number 4. They say given log 2 base a is 0.693, log 3 base a is 1.097. They said find log 13.5 base a, right? So see the same method. A, it says 1.404, B is 1.790, C 2.598, D 2.790, right? So let's go. Solution. So of course we're given log 13.5 base a. So 13.5, first of all, is same thing as what? 135 over 10 to move once. So I'm going to have, go to what now? Logarithm of what? 135 over 10 base a. So having gotten that now, we can reduce that 135 over 10. Let's reduce this. How many times can 5 go here? 5 can go into 13 2 times, 73, 27. 5 can go into 10 2 times. Right, so I'm going to have logarithm of what? I'm going to have logarithm of 27 minus what? Logarithm 27 base a minus logarithm of 2 base a. So what is 27 in powers of 3? Is 3 raised to power 3. So I'm going to have 3 log 3 is a. I'm jumping steps, right? Because I'm supposed to say 3 log 3 raised to power 3, but the 3 will still come here. So 3 log 3 over a. So 3 log 3 base a minus 2 log what? 2. No, not minus 2 log 2, but minus 2 log what? A. What's your 3 log a? What's log 3 base a? Sorry, is what? I'm going to have 3 into 1.097 minus what's your log 2 base a? 0.693. To do that answer, that question, the answer should be equal to 2.598. Right? That's your option C. All right, so I'll quickly give you an assignment at this juncture. Open your O3 Schools JAMB app. O3 School JAMB app. And then look for these questions and solve them and submit on WhatsApp. 2005 question 28. 2007 question 33. Right, so look for them, solve them, submit them. Use the WhatsApp number to submit 09121515246. Submit them. All right, so let's quickly move to another aspect. A very easier aspect that people feel that is confusing. It is not confusing. Sometimes you may be solving a question under logarithm or in logarithm, and then the base that you are given is not conducive for you to solve. It's not conducive. So in that condition, we do what we call change of base. So if you are solving in logarithm and then you see bases that are are not even similar, that are not related. So you can do something called change of base. For example, if you have logarithm of what? N to what? Base what? To base b, for example, n to base b, you can what? Do change of logarithm. You are changing logarithm will now be equal to, you can now introduce a new base that you can operate with, that is conducive for you. So you can have logarithm of what? N. Let's say the new base is base c, all over what? Logarithm of what? B to base c. So because it's a new base by what you're introducing, so the base will be common between all these two. Sometimes the base may even be the number that you're operating with. For example, if you can have something like this, logarithm of what? Um, of C to B, for example, right? Logarithm of C to B, you can now say it's equal to what? Logarithm of what? C to be C over logarithm of what? B to be C. So the base can also, even the new base we're introducing, can also be the number you're operating with, or that you're looking for. So in this case, you know that what? The logarithm of a number to the same what number is same to what? Is equal to what? 1. So this is equal to what? 1 over what? Logarithm of what? B to be C. So these are just the two ways what we can what? Interchange. We can use what? Bases that are convenient for us in change of base to solve, so that we can get a final response or an answer that is convenient. So now we are going to take what? Some examples, and then so that we can quickly what? Shut down for today. All right, so this is an example, the 2003 question from the O3 school JAMB app, question 1. So they said evaluate logarithm of 4 root 2. That started seeing what? Very uncomfortable basis. 4 root 2 plus logarithm of 16 base 1 over 2, then minus logarithm of what? 32 base 4. Answer A here was minus 5.5, B is minus 2.5, C is 2.5, and D is 5.5. So of course we know that the answer will either be 2.5 or 5.5. Whether it's negative or positive is the only other thing we have to determine. All right, so then let's go. So you can see what some bases, you can see the bases given here, they are very well pretty uncomfortable. So we can introduce a new base, let's say 2 for example. We can introduce a new base 2 that can work for all of them. So introducing a new base now, I'm going to have logarithm of what? Let's say 2 is the new base I'm introducing, 4 base 2 over logarithm of what? Root 2 to base 2. You get? Then plus logarithm of what? 16 to base 2 all over logarithm of what? 1 over 2 to base 2. Then plus, sorry, that's not a plus, minus logarithm of what? 32 base 2 over logarithm of what? 4 base 2. Right? So from here now, I'm going to jump steps so that we can be fast. Now this same thing as what? 2 log 2 base 2 over what? What does root 2 means? Root 2 means 2 raised to the power what? 1 over 2, isn't it? Yeah, so it's same thing as what? 1 over 2 log what? 2 base 2. Then plus, of course, what is 16 in the powers of 2 is what? 2 raised to the power what? 4. 4 log 2 base 2 all over what? 1 over 2. Okay, of course, now in this case, having what? 1 over 2 over 2. 1 over 2 is same as what? 2 raised to the power minus 1. Isn't it? Yes. So if I put in that here now, I'm going to have minus 1. Let's leave this plus here because normally this plus is supposed to change. But do not forget, you're going to have minus 1, right? Minus 1 log 2 base 2. Then minus, of course, 32 is 2 raised to the power 5. So 5 log 2 base what? 2 over 2 log 2 base 2. Right? So now let's start to work out. Log 2 base 2 will cancel log 2 base 2. Log 2 base 2 will still cancel log 2 base 2 here. Log 2 base 2 will cancel log 2 base 2 here. Right? So now what is left here? 2 over 1 over 2. Then Minus times plus is minus. So I have minus 4 over 1 is what? Is 4. Then minus 5 over 2. 5 over 2. This is what is left. So of course, this is division. The 2 will come up, right? So it becomes what? 2 times 2. I'm going to have 4 minus 4 minus 5 over 2. 4 minus 4 is 0. Minus 5 over 2 is what? Minus 2.5. Which is our rightful answer here. Option B. It's very, very easy. Very, very simple and sweet. So whenever you are giving unconducive basis, you have to what? Do change your base to a base that is convenient for you. Nobody inside your mind, this base can allow me to solve to get the answer. That's what you do. As simple as that. There's another way of solving this. I want to show you in the other example. All right, so let's go to the other example. So this is also a past question, right? Okay, so of course we don't treat any question that's not past question. All right, so let's go 1995 question. Question 8. They say without using symbol, evaluate log 4 base 2 plus log 2 base 4 minus log 5 base 25. So this is very, very easy. Now, of course, you can see this base is 2, this one is 4, this one is 25. Different bases. Why 2 can work for this and this, 2 cannot work for this. But there's another way you can do change of base. Because remember, I told you that what you can use what the same word number as the base. When we said log c base b is equal to what now? Log what? C base c over log what now? B base c. We will say it's equal to what? 1 over log b base c. You can use this law to solve here, even without doing all those change of base type. Now let's go. So this same thing as what now? 2 log what? 2 base 2, right? Then plus, right? Remember, this is 2 raised to power 2. 2 log 2 base 2. Then plus what now? Log 2 raised to power 2 raised to power what? 2. 4 is what? 2 raised to power 2, right? So express them in powers. Then minus log 5 raised to power 2. You get. Now, since the power is below, then instead of you to what, bring it back here, so you have to what, invert the power. In this case, you what, invert the power. So inverting power into 1 over something. So remember when, if it is here, for example, here now is what, log 4 base 2, which is set out log 2 raised to power 2 base 2, right? The power is on top of the number here. But this place now, the power is on the base. So if the power is on top of the number, we'll bring it back down here to what? 2 log what? 2 base 2. But if it is on top of the base, like it is here now, log 2 raised to power 2, we now say, well, we invert the power. So it comes to 1 over 2. It becomes 1 over 2 log 2 base 2. You get? So it's a very, very easy and clean way of solving also of doing your change of base without going through that lengthy process. So, so let's continue. I'm going to have log 2 base 2 is 1. So I'm going to have 2 plus. So this was 1 over 2. Log 2 base 2 will cancel again. Then minus what? This is what? 1 over 2 also. 5 log 5 base 5 will cancel each other. So of course now, plus 1 over 2 minus 1 over 2 will cancel. My answer is what? Just 2. Very fast and easy. Now, likewise, sometimes we'll be solving what? Logarithm equation and logarithm questions, and it will lead us to equations. So we also have what? Logarithm what? Equations. So let's see some examples under logarithmic equations, and then we call it a day. We call it a day. Part of what we are going to learn also is how we can convert logarithm to indices. That's why I said if you have not listened to our indices class, you have not watched our video on indices, go back to that class, watch it before coming back to this class. All right, so let's go. This is 1989 question 11. They said find P in terms of Q if log P base 3 plus 3 log q base 3 is equals to 3. So it's very, very easy, right? We're giving options, we're giving options, we're giving options. All right, but let's leave those options out. Let's solve. So this is solution. So we're giving what? Log p base 3 plus 3 log what? Q base 3. All right, is equals to what? Is equals to 3. Now, remember what this means, right? So this means what? Q raised to power 3. So log p base 3 then plus what? Log q raised to power 3 base 3 is equals to 3. When you're having addition, you are multiplying. So I have log what? 3, bring out log 3 out into p times what? Q raised to power 3. Then it's equals to what now? 3. Now, remember they say find p in terms of q. That means p is equals to what? Q something, something, something. So now we're having this. This is logarithm here. This is what? A normal number here. We have to what? Remove this logarithm from here. How do we remove logarithm? Indices. So to do that, simply what? Raise what? The base to the number that is what? That it is equal to. Let me show you. So what it means here is if this logarithm will live here, it means p times q raised to power 3 is equal to this 3 raised to power what? Raised to power 3. You get? So that what? P now is equals to 3 raised to power 3. You divide both side by q over 3. You're going to have all over what? Q over 3. Right? So P is equals to 3 raised to power 3 all over q over 3. Bringing it up again. So of course, this means that P is equals to 3 over q all raised to power what? 3. So this is what? Simple what? Simple answer to what? This simple what question. So to say find p in terms of q. So of course we use logarithm to get here, and then we've gotten our answer. Now to the last question for today. The last question for today. This one is the last question for today on this topic. The last question for today and for this topic is a 2004 question from the O3 School JAMB app, number 43. They said if 6 log 2 base x minus 3 log 3 base x is equal to 3 log 0.2 base 5, find x. A is 8 over 3, B is 4 over 3, C is 3 over 4, and D is 3 over 8. All right, so we're told here that if 6 log 2 of 2 base s minus 3 log 3 base s equals to 3 log 0.2 base 5, they say what? Find x. So it's as simple as ABC also. So work with me gently. We already know that this will mean what? Log 2 raised to power 6 base x, right? We're going to have log what now? 2 raised to power 6 base x minus log 3 raised to power 3 base x is equals to log 0.2 over 10. In fraction is what? Over 10 to move 1. So 2 here 1, 2 here 5. Let us reduce it. So I'm going to have 1 over 5. I'm going to 1 over 5 raised to power what? 3 base 5. We have gotten that. Alright, now let's continue. What does 1 over 5 mean? 1 over 5 means what? 5 raised to power minus 1, isn't it? For example, we can also apply it here. Alright, so we're going to have from your laws of logarithm, when you're having subtraction, it means what? You should divide what? You should divide what? Them. So I'm going to have log x into bracket 2 raised to power 6 over what? 3 raised to power 3, right? Then it's equals to what? 5 raised to power minus 1. Logarithm of what? 5 raised to power minus 1 all raised to power what? 3 is 5, right? Do not forget that and do not throw it away. So logarithm of what? X into bracket 2 raised to power 6 over 3 raised to power 3 is equal to what now? Logarithm of what? 5 raised to power minus 3 base 5. So this can come to the back of this logarithm, right? So I'm going to have logarithm of x into bracket 2 raised to power 6 over 3 raised to power 3 is equal to what now? minus 3. Logarithm of 5 is what? Is 0. So that one can go, of course. So now, what else do we need here? So we're having logarithm of x 2 raised to the power 6 over 3 over 3 equals to what? Minus 3. So to remove this logarithm from here, what do we do? From the previous example, what to do? We have to introduce what? Indices. So to do that, I'm going to have what now? That's 2 raised to the power 6 over what? 3 raised to the power 3 is equals to the base x raised to the power what? Minus 3. Right? So how do we simplify further? We have to simplify further. We cannot just end there because obviously the answer is not there. This kind of answer is not there. So, and again, we're not looking for x raised to the power and we're not looking for x raised to the power minus 3, but we're looking for x. So what do we do next? So we have to look for a way to what? To shuffle it. So this is the same thing as what? 2 raised to the power 6 is the same thing as what? 2 raised to the power 2 raised to the power 3 over what? 3 raised to the power what? 3. Isn't it? It's equal to what? X raised to the power minus 3. So this thing, because this is raised to the power 3, this is raised to the power 3, that means we can rewrite this one as what? 2 raised to the power what? 2 over what? 3, all raised to the power what? All raised to the power 3 is equal to x minus 3. Alright, I want you to be seeing everything clearly. So we rewrote this out and raised to the power of 3 equals to x to the power minus 3, but the powers are not equal, so we cannot equate the bases. So the bases are not equal, and so we cannot equate the power. So we need to make sure that one of them, at least one of them, are equal. This is 3, this is minus 3. How can we make this one to become minus 3? We have to, if we revert this one, if we make it 3 over 2 over 3 over 2 raised to the power 2, the power will become what? Negative. You get? That means if we are utilizing the law of indices that say x raised to the power minus 1 is what? 1 over x. So that means 1 over x is something as what? X to the power minus 1. Right? So if we want to have what? X over 1 now, right? Then if we want to invert it, so that means we need to what? Introduce what? Raised to the power minus 1. Are you together? So now that's the exact thing we do for us to be able to get a final conclusion on the answer. So doing that now, we're going to have what now? 3 all over what? 2 raised to the power 2 raised to the power minus 3 is equal to what? X raised to the power minus 3. So of course, the powers will cancel out, and that means x will be equal to what now? Now, because we have what? Equal powers, you equate bases. So doing that now, got to have that x is equal to 3 over 2 raised to the power 2 equals to 3 over 2 raised to the power 2 is what? Is 4. And our answer will be what? Option C. So in an exam condition, you have to be very, very fast. You have to be very, very smart. You have to think out of the box, right? If you do not find your answer on the question, you can leave it, do other ones, then come back to solve what? That question. So the last thing we're going to do now is to take assignment as usual. So taking our assignment now, and then we'll call it a day. Let's take our assignment and call it a day. All right, so assignment. Assignment from the O3 School JAMB app. So 1 log y raised to the power minus 1 over 4 plus log 1 over 2x over 4 is equal to 1, and log y plus 1 over 2 plus log s is 2 is equal to 2. Solve for x and y respectively. Right? All right. So the number 2 is 2012 number 43 from the O3 Schools JAMB app. From the O3 Schools JAMB app number 43 from O3 Schools JAMB app. All right, guys. Please do not forget to subscribe to this channel. Do not forget to give us a like. It is not easy. Give us a like. Give me a like. Right, and do not forget to comment the video. And of course, you can share this video to your friends and to your colleagues to make them also understand the topic better and also perform better in the examination. Download your O3 School JAMB app, activate it. Do not fear. Activate your app for 2,500 naira and get all the benefits that the app will give to you. Of course, this way we'll draw the curtain. See you in the next class.